Okay, so we're starting right off the bat without bell work, so ignore the spell work, but realize that we're working 12-3 determinants and inverses. Our objective is to learn how to find an inverse of a matrix, and we'll also work on determinants. The first thing we need to understand is what properties matrices hold. So we've got the product of a matrix and its multiplicative inverse matrix is called a multiplicative identity matrix. Now, what is the multiplicative identity matrix? It's a matrix who has ones on the diagonal and zeros everywhere else. Okay, so on a 3 by 3, it looks like, well, that was bad. It looks like this one over here, where the ones on the diagonal, zeros everywhere else. On a 2 by 2, it's going to look like, what? Do this one more time. Like this. Okay, diagonals have the ones. The ones are on the diagonal right here. And there's zeros everywhere else. Ones on the diagonal and zeros everywhere else. That's called an identity, multiplicative identity matrix. Okay? If A and B, if matrix A and matrix B are square matrices, and a square matrix is just a 2 by 2, it's the same rows, same columns. That's a square matrix. A 3 by 3, and these are the only ones we're going to be working with today. So it's square because it's the same number of rows as the same number of columns. 3 rows, 3 columns, right? So we call that a square matrix. So when you have square matrices and you multiply them together, matrix A times matrix B, and you get an identity matrix, then check B times A. So reverse the multiplication, and if you still get that same identity matrix, then you say these are multiplicative inverses of each other. Okay? So it's a lot of terminology to start off with, but let's put it in the calculator, and I think with you using it, it'll make much more sense. So let's go straight to our assignment, number 1. Okay? So turn on your calculator, and the first thing we want to do is clear everything. So turn it on, and then go second function, memory, which is the plus key, and then type 712, and it's going to clear everything out. It'll say RAM cleared, and then hit clear. And you want to do that before your test 2, just to make everything the exact same way every time you go in, because sometimes kids go in there and change different settings and stuff, and it can get really confusing, or they might have stuff left in there that you don't realize is there, and then you start getting strange calculations. So always clear everything out before a test, especially. So the one thing we want to learn how to do, yesterday we learned how to multiply matrices, and we learned, you know, for a 2 by 2 matrix to multiply it against another 2 by 2, it's pretty easy. But we learned when it gets to be a larger matrix, it gets a little complicated to multiply them together, because you're going across the row and down, you know, and you're going different directions. So the bigger the matrix, it's a little more tedious to do. Today I'm going to show you, we did it by hand yesterday, today I'm going to show you how to do it on the calculator and make it easy for you. So let's start with the 2 by 2. To enter a 2 by 2 matrix, and we're going to call this our matrix A, and the second one's going to be our matrix B. Let's enter matrix A first. To do this, you want to look for the gold letters that say matrix, and they're right down there on that inverse key, the key that says x to the -1, that's our inverse key. But look above that. In gold letters, there's MATRX. That's your matrix key. To activate the matrix key, or any of the gold letters, you have to hit that gold button, the second function. So hit second, matrix, And it brings up our matrix menu. And notice the first thing is just the names. So there's all sorts of names for matrices, and it looks like it goes on, but we've got A through G there. Well, there's nothing in them. If there was something in them out to the side of the A, it would have like a 2 by 2. It would tell you the size of the matrix. These are all empty because we cleared everything out. So we want to go over and to edit, because we want to put things inside the matrix. We have to edit them to put stuff in it. So go over to edit and make sure A is selected, number 1, and press enter. The first thing we have to do is tell it the size, the dimensions of the array. Well, we're entering a 2 by 2 array. So enter 2, enter, 2, enter. So at the top now it should say matrix A 2 by 2. Or 2x2. Everybody got that? Next, it took you inside the array. So now let's just start entering the numbers. We've got 2, 1, 6, 4. So just press the number 2, enter, and enter will take you to the next field. 1, enter, and it'll take you to the next field. 6, enter, and 4, enter. It's done. That's how quick it is to put a matrix in. Now, we have to quit out of this. Now, the quit is in gold, so to activate that, you have to hit that gold key. So hit second function and quit, and it quits out of it. It's still there, and it's going to stay there till we clear it out or override it. Now, we're going to do the same thing again, but for matrix B. So go to matrix menu, over to edit, and guys, I'm going to come by and check, so I want to everybody needs to be doing this. All right, now arrow down to B, or you can type number 2. All right, once you're there, press enter, and now matrix B is also a 2 by 2. Now, one thing I need to tell you before you go crazy on me, the negative half right there, you have to use a negation key, the little hyphen between enter and decimal. Okay, that's your negation key. So I'm going to put my first element in 2, enter. The next one is negative 0.5. You don't have to type the 0. So it's the negation key 0.5 and enter, and notice it says negative 0.5. Next is negative 3, so negation 3, enter, and then 1, enter. Everybody there? Anybody need help? This lesson's going to run to the bell. So if you get off, don't wait till way down. Tell me as soon as possible so I can keep this lesson on track. Otherwise, we're not going to make it. All right? Okay, so quit out of this one. Now, what we have to do, that little rule that said, okay, find out if they're multiplicative inverses. Well, we've got them both entered, so what we have to do is A times B and see if it makes that identity matrix. So let's do that. So for matrix A, you just have to go back to your matrix menu, and under your names column, notice that A and B both have elements in them now. 2 by 2, 2 by 2. We'll just press enter on A. You don't have to do anything except press enter. And now hit your multiply key, times, and now pull up matrix B. So matrix, I'm going to use my cursor key to go to 2. So now it's on B and press enter. So now it looks like matrix A times matrix B. Press enter one more time, and it gives you the answer. So do we have ones on the diagonal? Yes, because it looks like this. 1, 0, 0, 1. We have this. So there's an identity. Now, we've done A times B, and it checks out. Now we have to do the same with B times A. So repeat the process, doing B times A. See if you get the same thing. And don't clear this out, because this is what I'm going to be checking. So matrix B times matrix A. And again, I got the identity matrix. because I got the identity matrix both times, I can say yes. So my answer is yes. It is. Okay? I'm going to pause this and I'm going to come around and check everybody's work. All right, so everyone in the room's done this, so congratulations, yay. Now we're going to turn it up a notch. So I want you to work number 2 now. So what you're going to do is go back to your matrix A, and when you go inside there, you're going to have to tell it. Here, let me show you. I'm going to clear my screen, get everything off that. Now, I'm going to go second function, matrix, and I'm going to go over to my matrix A again. Edit and enter. It says 2 by 2, but my next matrix is a 3 by 3. So just type over it. 3, enter, 3, enter. And now we're going to put in these next 2 matrices. So 2, just type over it. -4, enter. 1, enter. 6, enter. -3, enter. -7, enter. 9, enter. 5, enter. And -2. It's hard to do with the mouse. And now my matrix A is finished. You might double check before you get out that all your elements are correct. And mine are. So quit out and then go back to matrix B and enter the next matrix. So down to B, enter, and again it's a 3 by 3. And this one is 8, 3, -3, -9, 2, 7, 4, -1, -6. Okay, so once you get those entered, then do the B times A, or sorry, do A times B first. And when you press enter, do you get an identity matrix? Do you have the diagonal ones with the zeros on each side? Those look like 6s. So if you have an identity matrix, then you would go and check B times A. So do we have an identity matrix here? No, it's not even close. And I'm sure my data is right, and I've done this like 4 times today. So this, because this is an identity matrix, we have 56, -3, -40, 47, 19, 3, and then 19, 39, and 20. Because we've got that crazy thing, it's not the beautiful 1, 1, 1 with all zeros, then we say no. They are not multiplicative inverses. You can stop right there. You don't even, they have to both give you the identity matrix. As soon as one doesn't, you're done. You just say no. So this one was a yes, this one's a no. So now I'm going to leave you with number 3. Do number 3 on your own real quick, and then we'll continue. And I'm going to pause the video again. So what do we get? Yes. So that's the correct answer. So good job. So there's one of those on the test. Now you know how to enter a matrix, and you know how to decide if it's an inverse. Multiply them together both ways. See if you get that identity matrix. Now yesterday we learned how to multiply those by hand. So remember, we did just the same thing, but we saved ourselves a lot of time by entering it in the graphing calculator. The yellow calculators don't do this. So you will get one of these on the test, okay? Now we're going to learn about something called a determinant. Every matrix has a determinant. It's a number that's just associated with it, and there's a way to calculate it. How we calculate it when it's a 2 by 2 matrix is super, super simple. what we do, let's look at number 4. Actually, let me go to number 4. There it is. And ignore everything else here because there's a lot of writing and scribbles on it. Right, so for number 4 here, to get a determinant, you're going to multiply this diagonal, the one that's the backslash, so 4 times 3, and you're going to subtract from that the other diagonal, negative 5 times 1. Okay, so what does that equal? 4 times 3 is 12. Negative 5 times 1 is negative 5. So let me write in a clear spot. We have 12 minus negative 5. So minus a minus goes to what? A positive. So our final answer is 17, 12 plus 5. So our determinant for this matrix right here is 17. So you could, I would write that in so you know how to calculate it by hand. It's much easier to do the 2 by 2 matrices by hand than to type them in. So it's just 4 times 3 minus negative 5 times 1, which is 17. Okay, now do number 6 and do number 8 the exact same way. So 2 times 4 minus, and then do 8. Okay, you should be pretty close to finished. Except for number 6, you got what? 2. And how about number 8? 1. That's correct. So if you didn't quite get there, just go ahead and pencil in your answer so you can make sure you can work to that tonight at home. Now I'm going to move on to the next thing, which is now we're going to get a little more complicated. Not hard, just a lot of little rules, a lot of tedious things. To find the determinant of a 3 by 3 array, matrix, it gets a little harder. But all you have to do is take the first 2 columns. So we have a negative 1, a 6, a 5, 3, negative 2, 7, and negative 4, 8, negative 3. Okay, so to do a determinant on a 3 by 3 matrix, you're going to copy the first 2 columns again at the end of the row, or end of the column. So do the first column, negative 1, 6, 5, and now copy the next one, 3, negative 2, 7. You see that? So I just copied these first 2 columns and put them right there. Now we can calculate our determinant. So on a 2 by 2 row, this is how I remember that it's 3. On a 2 by 2, we were multiplying 2 numbers together each time and subtracting each diagonal. On a 3 by 3, we're going to be multiplying 3 numbers together. But we have 3 of those. We've got 1, 2, 3. So we're going to add those together. Multiply the diagonals and add those diagonals together. So let's do this. It's going to be 5, I'm going to use this, 5 times negative 2 times negative 4, so there's that one, plus the next diagonal going this direction is 7 times 8 times negative 1, plus the next diagonal going that direction, negative 3 times 6 times 3. Okay, that's the first part. Now let's go ahead and calculate this and get it down to one number. So this is going to be a negative 8 times 5, which is, positive 8 times 5, which is a positive 40, plus is going to be a negative 56 minus 9 times 6 is 54, assuming I didn't make any errors there. So adding these together, I'm going to have 110 minus 40. How about negative 70? Okay. I'm going to pause. Okay, so on this diagonal, this is my second number. This is what I'm subtracting, okay? This is the second direction. Really, the first direction, the first number goes the backslash, just like before up here. That was your first minus that. Same thing here, so I actually just calculated the second term, right? So we'll hang on to that. I did the same thing last hour. I'm just getting stressed because I know I'm not going to finish this lesson. All right, so let's go to the next one. Let's go get the first diagonal. And this one's going to be, I'm going to clear this out. So we know my second one's negative 70. So we're going to go get the first one. So this is your first one. Go in this direction. It's always the backslash first. This way minus that way. Okay? So let's get the first number. Negative 1 times negative 2 times negative 3 is going to be a negative 6. 3 times 8 times 5, well, that's 40 times 3, it's 120. And then 7 times 6 is 42 times negative 4 is negative 168. Okay, so that goes to 114 minus 168, that's a negative 54. So we end up with negative 54 minus negative 70. Remember, the backslash diagonals always go first. Those added together, those products added together, minus these products added together is your determinant. Okay? Now, that comes out to negative 54 plus 70, which comes out to a positive 16. Now, let me show you the easy way. So, plug this into your calculator, just the 3 by 3 matrix. Okay, and I'm going to go to matrix A. Whoops. I keep grabbing my hand one and not the example one. Clear your screen. Matrix A, and I'm going to enter a 3 by 3 again, so enter, enter. And we're going to enter this data. So, negative 1, enter, 3, enter, negative 4, enter, 6, enter, negative 2, enter, 8, enter, 5, enter, 7, enter, negative 3, enter. And I hope that's right. So I'm going to quit out. And now I'm going to double check my determinant. So hit your second function, matrix, again, and go to math, the middle one. Notice that the number 1 is determinant, DET, so just press enter. And what do we want? We want the determinant of the matrix we just entered. So go matrix A and enter. Determinant matrix A, 16. Oh. So the angels sing, the heavens have parted. So there it is. How easy was that? So do you prefer, how many of you prefer to do it by hand? How many of you prefer the calculator? Yeah, I would too. So, but you've got to know how to do it by hand. I had to show that. But you see it's tedious, and even moi makes little mistakes. So those mistakes are count. You know, you want to double check everything. So know how to do it by hand, but understand how to check your work with your calculator. And on a test, who's going to know what you used? Hand or calculator? On a test, I'd probably use a calculator. All right, any questions about that? So if we have enough time, we'll come back and plug in 7 and 9, but I've got to move on. I want to show you, we're going to work this in the calculator, so keep it on. When we can use determinants to get areas of triangles, and all we're going to do, and flip over to the back of your paper, we're going to work 12 and 13 real quick here, and then we're almost done. So on 12, notice that we have a triangle here. We can use a 3 by 3 matrix to get the area of this triangle. What we're going to do is use the coordinates, the 2, 2, the 6, 4, those start each row, and 5, 8. Okay, so there's my 3 rows, and we're going to finish it out with a 1, a 1, and a 1. So just finish each row with a 1. So it's the coordinates. 2, 2, 1, 6, 4, 1, 5, 8, 1. Everybody with me there? Okay, now take the determinant of this and divide it by 1/2, and you've got the area of that triangle. So let's plug this into the calculator and get our determinant. Whoops, I did it again. So get your calculator, and let's enter these in. I'm going to hit clear, go to matrix, edit. This is a 3 by 3 still, so enter, enter, and enter 2, enter 2, enter 1, 6, 4, 1, 5, 8, 1. All right, and then get your determinant. So quit out, go back, math, enter, matrix A, and I have that the determinant is 18. I hope that's what you get too. So then we know the area is 1/2 of 18. So our area is what? 9. That's all there is to it. It's 1/2 the determinant. So the area of that triangle is 9. Any questions on that? All right, the next one's a little tricky. So look at the shape of 13. How many triangles are in that? 2. So be careful what you choose for coordinates, okay? So I would choose 1, 2, and then put your 1 behind it. 5, 5, 1, and 5, 9, 1. And get the determinant of that. And let's get the area of one triangle, right? So tell me what that determinant is, and we'll take 1/2. Oh, I got an error. What did I do? I went really fast, so I probably made, oh, I did totally hose that up. So hard to do with the mouse. Okay, so did you get 16 for your determinant? So that means that the area of this one triangle is 16, right? Uh, 16 divided by 2, which is 8. So 8 for one triangle. Sorry about that. So if I wanted the area of all this, I would double it, right? So the total area of this shape would be what? 8 times 2, which is 16. All right. So everybody see how to do those? Any questions? All right, we've got just enough time to finish and then go back and get your other two. This will be the first time today. So good job, guys. All right, let's look at the inverse. There's ways to do an inverse. And to get an inverse, we show inverse of matrix A looks like this, a to the negative 1. And if you notice, there it is. You've got x to the negative 1 on your calculator, right under on the matrix key, right? So that's the key we're going to use. So I'm going to show you in theory how to do it by hand, but I'm going to show you how to get it on the calculator, all right? So if we have a 2 by 2 matrix, to get the inverse, you're going to take 1 over the determinant of that matrix. And you're going to take, if your matrix is A, B, C, D, you do 1 over the determinant times, and now we're going to change the order. It goes A, B, C, D, and then negate the 2 on this diagonal. Whatever they are, negate them. That's how you do it. So let's look at one example. Okay, we'll do number 14 in your book, and then we'll do 15, 16 with the calculator. So if we have, here's A, matrix A. So we know this is our A, B, C, and D. So if you get the determinant of this, it comes out to, what is it? It's 1 over the determinant, right? So it comes out to 2. So when you plug this into the calculator and hit determinant, you're going to get 2. So the inverse of this is equal to 1 over the determinant, which is 2. Oh, and they had it right there. Sorry. And you also know the determinant is 6 times 1 minus 2 times 2, which is 6 minus 4. So you didn't even need it in the calculator. Remember, the 2 by 2s are the easy one. So the determinant is 2, 1 over 2 times, and now we're going to change the order. It's going to go A on the bottom, so it's going to be 6B up here, which is 2, C, which is 2, and D is 1, and then negate these two. So just flip the signs, whatever they are. So now we're not done because we've got to clear that 1/2. So now we're just going to take 1/2 of everything here. So half of 1 is 0.5. Half of negative 2 is negative 1. Half of that negative 2 is negative 1. And half of 6 is 3. So there's your inverse. 1 over the determinant times that different order. Now let's do it. Let me show you how to do it with the calculator. I did it again. All right, so go to your calculator, hit clear, and let's enter this matrix. So it is a 2 by 2, and it's 6, 2, 2, 1. Okay, so now once you get that, quit out, and now I want you to type in the matrix A, so bring it back up, and now just hit the inverse key, the x negative 1. So it looks like matrix A negative 1, and now press enter. Oh, isn't that what we just got a minute ago? Yes, it is. So that's how you can also get your inverse. So 0.5, -1, -1, and 3, which is what I had just a minute ago. Right? So remember, you can do it either way. So take the rest of the time, we have 7 minutes, which is more than we've had in any other class, to do 15, 16, and then go back and catch, what was it? 7 and 9. And everybody else was actually doing these by hand without a calculator tonight at home. But remember, it's the backslash diagonals minus the / diagonals. Okay, don't make my mistake of reversing that. All right, and that's everything, guys. Whew, this completes our lesson, and this is the one I'm going to put out there tonight. So thank you. And one more lesson and we're done with the book. This is it.